industries in our country is basically still working or still operating with the third generation or the third revolution of automation. Whereas the rest 10% has slowly eventually started moving towards this fourth industrial revolution, which we also refer it as Industry 4.0. So I would like to share my screen first. So I hope my screen is visible to all. Sir, can anyone confirm me that my screen is visible to everyone?
Yes, sir. Yes, sir.
Okay. So basically, I am working for a company called HYDAC India, whereas my past experience was almost for the last 20 years, I've been working for the automation industry and probably in very different range of companies, starting from a very small solution-based company that is a special purpose machine manufacturing company, and to one of the biggest MNCs also I have worked. I have seen the difference and I've seen that particular technology growth, which I would be very happy to share it across to everyone. So even in HYDAC, this is basically a multinational company. It's a German company. It's basically from Germany, but we are aggressively moving in India with around 5 manufacturing plants. And our concentration also is slowly shifting, rather than I'll not say shifting our way. We have a very strong base with automation, but slowly we are enhancing and trying to promote more and more of Industry 4.0. One is to the industry and second is to the education sector also, because once the industry gears up, the required skill set will be very difficult for the industry to train the new engineers. So we want engineers to come out with these particular skill sets here. So I'll be just giving a brief introduction about HYDAC, which will not take much longer time. And then we'll go into this, our main topic, that is Industry 4.0, which I generally refer it as, this is the emerging trend in automation technologies. So as I said, we are a German-based company with a very strong base in India, because apart from Germany, India is the only country which has got 5 manufacturing plants. So again, we are not a single company, it's a group of company where we cater to very different product ranges and solutions. So we basically supply a lot of components related to hydraulics, then sensors, as well as data acquisition and Industry 4.0 solutions. And the next is we also manufacture systems, which is a part of a bigger mission. So we customize and engineer a dedicated function through our systems and we supply to them. And last but not the least, we are global leaders in fluid engineering and services. So our main focus is in the research and development of fluids used especially in the field of hydraulics, whether it is for industrial sector or for defense sectors. So we work a lot with fluid engineering. So with this initiative, so one is we want to upgrade our technologies. We are shifting to Industry 4.0. We are helping build, our customers also build this particular competence. But at the same time, we also have a very noble responsibility or a social responsibility, where we try to partner with education institution and try to establish a synergy kind of thing where students can work with the products which have been used in the industry and they can acquire that skill set before they join the industries. So, and HYDAC is one of the company which is playing a very role in building very innovative solutions to the existing projects, existing missions in a way of incorporating Industry 4.0 into it. So we'll get into the topic. So I'll try to be focused more on the application front and how is it different from the existing technology. We'll try to cover up all the things. So yes, so basically the backset for this Industry 4.0 is industrial automation, which is we refer it as the third industrial revolution. So when we talk about industrial automation, it is already widespread, especially in developing countries. It is still a very rapidly growing sector. Now we have a cherry on the cake with Industry 4.0. So, but to understand Industry 4.0, it is very important to understand its back foot, that is industrial automation. So, in a very simple words, if I have to tell you what is industrial automation is, it is the use of control systems which can be catering from various different technologies such as computers or robots and information technology for handling different process and machinery in an industry. So the next thing which is written as to replace human being, I am slightly differing to this particular statement. So it's basically to assist human beings so that the work quality can be improved. So this industrial automation, whatever is being, which is there in the industries, we refer it as the second step beyond mechanization. So in a very simple graphical way, so we have control system, and this control system incorporates of multiple things, whether it can be a hardware, it can be softwares, or it can be a computer which can take decisions, which can be used as a programming tool. Multiple things go into a defined control system, which is meant to control and monitor some parameters on the missions. So when this is incorporated onto a mission, so instead of a sequential work which was earlier being done by manual labor can be automized. So humans are always prone to make errors when it's a repetitive jobs. So those jobs can be easily done by machines, and the intellectual strength what we have in human beings or the manpower can be utilized for a better jobs in the engineering sector. So as and all we know that these missions or instruments all are established within an industry or a factory to define or to manufacture a product. So then this is a very common terminology in nowadays, that is IoT, which we also refer it as Internet of Things. So this is not a new name. It is there in existence since almost close to 2 decades now, but it was not entered into the industry. It was mainly helping out in the consumer areas and domestic applications, which became very popular with a lot of other concepts coming into IoT, which made our simple example is a smartphone, which made it much more intelligent, much more useful, and with very rich in features. So somewhere back in 2008, a group of big industries along with the German government, they all came together and started discussing that the Internet of Things has already changed the face where people are using smartphones. Your domestic applications are becoming more and more popular. So now, why don't we try to adopt this particular technology in industry? So with this particular small idea, it all started. And then eventually by 2012, we had a concrete functioning components and modules which could be utilized to enhance a automated mission. So this has been in the rapid growing phase since the concept was initially thought. So in way back in 2008, when the concept was initially thought, it was only a concept. Rather, there were no guidelines, there were no practical case studies or anything. So all they wanted to do is bring this Internet of Things and merge it with the existing automation. So over a period of time and even till today, there are new concepts, new methodologies, new innovative ways we are bringing in, trying to bring in where we can enhance the quality of production, mission life, and many other things, which we'll see over the coming slides. So when it's a combination of IoT and industrial automation, a new name was given to it, that is Industrial Internet of Things. So it was the same Internet of Things, but it was brought into industries. So the moment it was bought, we had some concepts already with IoT, but there were many open challenges or open areas where we could build our own concepts and to enhance the missions. This is where it all started. So when I'm saying this Industry 4.0, 4.0, this I also we refer it as the fourth industrial revolution. So if this is the fourth industrial revolution, there should have been the revolution 1, 2, 3, and now we are in the fourth revolution. So I'm sure everybody have heard about these things. So the first industrial revolution was way back in the 17th century, where invention of steam engines, usage of water power using water hydraulics all started. So which could slightly bring in a more advancement into the manufacturing sector. So prior to the 17th century or in the early 17th century, every product used to be made by hand. So by invention of mechanical concepts, mechanical aspects, the production became easier and faster and effective. This particular technology or this particular revolution ruled the industry for almost a century. And almost after a century came the second revolution, which we call it as electrification or mass production and usage of electricity. A very initial thing was invention of electric motors, then usage of punching systems and many things. This revolutionized the industry. So in one of the article, it is mentioned that the first company to implement this electrification was the Ford car manufacturing sector, where initially on an average in a day they used to manufacture 1 or 2 cars, and by implementation of electrical concepts they were able to bring it to 10 folds higher. So this is how the face of industry changed with Industry 2.0. And again, almost after a century, the invention of microprocessors, microcontrollers, computers usage, these all led to a new generation of components where we call it as basically the automation. So in this particular era or the revolution when it came, so it was not again from 1970 everything popped up. So this development started happening with usage of microprocessors, microcontrollers, which led to n number of components, and it is still contributing a lot. So we can just to name few, it can be your programmable logic controllers, it can be your variable frequency drives, permanent magnet DC motors, AC servo drives, DC servo drives, and again, these again further implemented onto hydraulics, pneumatics, control systems, and everything. So this is one area which led to revolutionization of mechatronics sector. So where a lot of flexible manufacturing systems and even robots, as simple as a Cartesian robot or as complicated as articulated robot, these were all the outcome of the third industrial revolution, which is still dominating our Indian market. But now we have the fourth industrial revolution, which in a single terminology, if I say, it is connected industries or connected missions, which can talk to each other over the intranet or the internet, which can exchange data. So this is what we actually mean by Industry 4.0. So for Industry 4.0 to be successful, this IoT overlay or the cloud has to be implemented on the third industrial revolution. So it is known by very different names. So especially when we go to the European countries, they predominantly refer it as Industry 4.0. The same way, if I go to Western countries, it's referred as smart automation. In a generalized way, it can be called as digitization, connected industry, or appropriately, it can also be referred as industrial Internet of Things. So as I told you, the concept started with a small discussion in 2008, but by 2012 we had concrete products which could be used for this particular technologies. So now, in a general way, if I again go back one step behind, what are the technologies which are contributing in industrial automation? So there are n number of technologies which go into automation, but I've tried to pick up few very highlighted technologies. So one is hydraulics, second is pneumatics, and third one I've generalized it as drives and controls, which can be your PLCs, SCADA, closed loop controllers, or drives, everything. So these all technologies have been contributing to us since the inception of automation. So even with Industry 4.0, we had water hydraulics. So, but since then, these technologies also have grown to very innovative levels. So just to have a feel of it, I've just taken an example of a hydraulic technology where it all started with manual hydraulics, which could be operated with human interventions. Eventually, it was upgraded to electrically operated hydraulics, where usage of solenoids came into picture. So the moment that came, I could remotely start a mission, stop a mission, or do modifications in that. So then came, so it was basically referred as electrical operated hydraulics, is also referred as on-off control kind of hydraulics. The next came is continuous control hydraulics, or also referred as proportional hydraulics, or also called as modulating valves. So these were possible only because of incorporation of electronics into it. So there were a lot of microprocessors, microcontrollers, op-amp, where I could control the current using PWM switching, and many things were possible with continuous control hydraulics. And the next came, the demand started increasing for higher dynamics. So then next came was servo hydraulics, which was very fast. And the next came was digital hydraulics, where it was a breakthrough between your hydraulics to connected hydraulics. So usage of software tools, computer to program a particular hydraulic valve was possible through this. So with this, the ease of installing a thing, customizing a thing, which predominantly help the industries. And today we are in a generation where we call it as connected hydraulics. So in this particular connected hydraulics, it is very similar to the rest of the things. So the valve does the same function which was done by a manual or a continuous control hydraulics. But only thing is, when the valve is working, it also collects a lot of information on the valve characteristics. It can be a spool position, the current drawn by the solenoids, what is the temperature of the solenoid, what is the temperature of the fluid, what is the hydraulic pressure inside that particular valve. Everything could be monitored, and at the same time, the data could be transmitted over internet and stored at a secure place. So now there might be a question saying that what is the use of collection of data? So in today's generation, data is everything. So if we go end up in a shopping mall, just in a piece of paper, our number is there. So next day you'll start getting messages, and the way you use your smartphones for in the social media also based on your search histories, it will automatically start giving you suggestions. These are all possible because of collection of data and then using that data to improvise your experience with that particular device. So now the same thing we started implementing into hydraulics, where we started collecting a lot of data and started studying on that particular trend which it is being followed. So in case if the temperature is high, then the current drawn what it should be, or when it reaches certain temperature or the critical current solenoid, then there are possibility of failure of the components. So using data, we could do a lot of things, saying that improvise the performance of the machine, improve the life of the components. And now we are in a stage where I can even predict when this machine or this valve is going to fail. So we are scaled up hydraulics from a very raw level to a very, very advanced level now. So this is how the growth of hydraulics has been. And on the same lines, the growth in the case of pneumatics or any drives and controls for that matter is in a very, very exponential way. Now, where these particular technologies are used in the industry. So we have just taken a case of few critical companies or few critical sectors where automation is predominantly involved. So on the x-axis, we can see that we have got steel, cement, automotive, railways, mining, machine tool, press, defense, oil and gas, power, everything. And with different colored graphs, you can see the contribution of each and every technology in various industries. So where we take any technologies, everything has a very, very important role to play in each and every sector. So this is not replaceable. So the moment the misconception between students is the moment industry 4.0 is creating a lot of buzz sound in the industry, everybody wants to learn about industry 4.0, but that is not the case. The basics will remain the same. The technologies which does the work remains the same. Only thing is it is going to be overlaid by industry 4.0. So if industry 4.0 has to be implemented onto a mission, the base for that is your technologies, and that technologies cannot be changed or replaced with any other things. So it is very, very important that the technologies is already playing and will continue to play a critical role in the industry. But again, industry 4.0 will have will add more and more functionalities into this. So at the same time, there is one more very important thing which we have to see is in any automation sector or any automation product, the role for software is increasing exponentially. So this doesn't mean that the scope for mechanical and electrical or electronics is decreasing. The role of software is increasing, whereas mechanical and electronics will continue to contribute in this sector. When it comes to the contribution part only, more of intelligence is being incorporated through software. So what has caused this rapid change is, see, there is a small statistics here. Way back in 1995, there were around only 40 million connected people across the globe. And by 2020, we had around 7 billion connected people. And next is across the globe, way back in 1997, there were only 6 million computers which were connected to the internet. Whereas in today's generation, we have around 50 billion connected things. So earlier it was only computers, now it is connected things. So a very simple, at a residence itself, you've got your smartphone connected to the internet, you've got your TV connected to the internet, your ACs come with Wi-Fi, your lighting systems come with connected to internet, everything. So now to add on to this, we have our industrial components, your component level or the machine level, everything is connected to the internet. And this is only possible because now we are able to handle large amount of data on a secure networks. So what has caused this particular rapid development is, many things are mentioned here. One is due to mass production and the demand, the prices of the sensors is going down and data is playing a very, very big role. So a collection of data, only when I have sufficient amount of data only, we can further implement artificial intelligence, machine learning to improvise, and self-learning, all those are possible. So data becomes very, very important. So CPUs are available for cheap. You can have a single board computers or industrial grade microcontrollers which can do data acquisition at a very, very fast rate. Internet is available worldwide at a very, very reasonable cost now. And cloud-based storages are a lot are available. And also increase in software and its relevant hardware usability has increased. So no more an engineer and maintenance engineer in a fully automated plant will hold a multimeter or a spanner set to go and troubleshoot or measure anything. Just a smartphone would be enough for him to go and monitor the parameters as well as do the changes. But with all this, the biggest concern in this particular sector is the data breaching and data security, cyber security. Because when a company is completely automated, the data is in the cloud, and that is the only thing which has to be secure. So anybody who can breach into that particular data, they can destroy the whole mission virtually. So data security plays a very, very important role. So there are various sectors which are growing a lot. Automotives are becoming smarter, household equipments are becoming smarter, whereas our focus today is industry becoming smarter. So it is not only the things which we are making smarter, but how we produce these things also has to be smarter. So with that focus, Industry 4.0 has emerged a lot. So apart from that, smart cities, smart healthcare, these are all the buzzwords which you are hearing on a day-to-day life. So I've been referring since the starting whether that this is a fourth industrial revolution. So the biggest question when it comes to say to ask is whether it's a revolution or it's an evolution, because I told it started way back in 2012, and till today there has been a tremendous enhancements which are happening in this particular area. So in fact it is both. So business wise it is a revolution, because the moment so for example you want to sell a TV, if I sell a conventional TV without any features, it's difficult to sell it. But the moment I'll say that it can connect to the internet, you can stream from your mobile, everything, so it's easier to sell that product. So it was basically a business revolution. But when it comes to the concepts and products, it is an evolution, and still this evolution is happening. So uh, big industries or everybody predicts that this particular evolution is going to happen at least for 1 or 2 decades, because advancements will keep on coming on this. So very simple definition of Industry 4.0. This particular revolution 4.0, we refer it as a people-centric revolution. So people, missions, and IT systems automatically exchange information for manufacturing a product. So it can be within a factory, or it can be on multiple ICT systems within a group of companies. So this is, as I told you, it's a human-centric technology which will cut jobs at certain levels, but it will also open up a lot of opportunities and job openings, which is at a different level. The skill sets are different. So in other simple words, it's a merger of industry and information technology, where each of these particular areas will contribute to a lot of things. So whether it can be mission safety, time to the market, energy efficiency, productivity, life of the components will be the prime focus for the industries, and this will be overtopped by things like cloud computing, data mining or big data, or you have to ensure the safety of the mission from human beings, and at the same time safety of human beings from the missions. So where we have a lot of sensors and intelligence built into it. Then networking is a big challenge, because just taking an example of the company which I work for, HYDAC, we have got around 60 manufacturing plants across the globe, and everything are connected to each other. So getting this particular network set up, a very secure channel to transmit or exchange data, is very, very important. Once we have a sufficient large amount of data collected, then artificial intelligence and machine learning can be applied to enhance the quality of production, safety, and optimizing the process. So under this particular Industry 4.0 itself, there are several different branches which has emerged in this recent years and contributing to the industry. So those are autonomous robots, cyber security is being scaled up to a whole new level, then augmented reality, virtual reality, mixed reality is trying to enhance the user experience of the operators, maintenance engineers, everybody. Additive manufacturing, so all these days we had 3D printing with plastic materials, but now we have got metal depositions possible where prototyping, everything can be done at a very, very faster rate. And this technology is emerging in such a way that this technology can also be used for mass production of components. Big data analytics, cloud, horizontal and vertical communications, because if I have to communicate between 10 machines within a factory, we refer it as horizontal communication. And when there is a group of companies and each factory has to communicate or exchange the information with the other factories, then we call it as vertical communications. Then we also have a new branch or a very emerging thing which we call it as cyber physical system or a digital twin or a simulation thing, which is also emerging and helping out in the for making new production, changes in the production line, how it will affect the actual production. Everything can be simulated onto a virtual world. So this is possible because of this digital twins or cyber physical systems. So the smart factory or the future of process automation, basically, what is that industry needs? Industry needs is lean management. So there should not be much of inventory. So it should be in a concept of just in, just out in manufacturing sectors. Improve the quality of production. So reduce the rejection rates. Increase the energy efficiency. So when I have, for example, I've got a machine which does a continuous job, and at certain small steps of its job, the motor can be turned off. And by doing so, I can save energy. So a lot of things can be optimized, which we are looking for. The next is use of unskilled labor. As I told you, that certain jobs may get eliminated, but at the same time, Industry 4.0 is also creating a lot of job opportunities. So conventionally, today's ITI holders who are doing the assembly work, so they have got a better skill set to do something else. So the purpose is to use unskilled people, take them, and they can be slightly tweaked to do the assembly works, and ITI people can be used for supervision. So diploma engineers can be scaled up, and engineers and graduates, they can be used for creating innovative solutions, because that is the need of the hour now. So real-time data is required. So just as an example, so when we when we have visited industries somewhere around 10 years back or even 5 years back, so there used to be a huge notice board with all the production rate, rejection rate, and what is the plan for today, everything. So actually what was being put there was yesterday's data. So what had happened in the industry, the same data used to be collected, manipulated in forms of charts, and then put on the notice board, so that we try to understand what went wrong yesterday and what we can correct today. So that was the concept all these days. But with Industry 4.0, now we have real-time data. So instead of a notice board, it's a huge LCD display where actual data of the machines are being projected in a graphical way or tabular form, where we can see if there is any deterioration or any intervention is required to streamline the process. So unlike earlier, in today's automation sectors, we can mass produce one component also. That means the quantity can be one. So I can have 1,000 variants, and to produce everything, I don't have to change the line or change the program or anything. With Industry 4.0, all the data can be pulled from the cloud. Machine can adapt by itself, change the programs on its own, and it can do one piece mass production. So very, very important thing, the last point here. So what industry needs is zero breakdown. So in order to achieve zero breakdown, what we are following in the industry today is perfect preventive maintenance. So on a scheduled basis, every 6 months or every yearly once, we stop the machine for a couple of days, do all the checks, replace necessary things and everything. But now this has got changed from preventive to predictive. So with lot of real-time data, artificial intelligence, machine learning, I can start predicting that the component has deteriorated and next week, Wednesday, 2 o'clock, this component would fail. So today itself, I can plan to procure the new component, and instead of stopping the machine for entire 2 days to do all the checks, I stop it for 10 minutes, replace the component, and your production is back to full swing. So these are all possible with Industry 4.0. So finally, what are the benefits of Industry 4.0? It is very flexible. We can use a lot of high-level programming languages. So Python, Java, C++, C Sharp, everything can be utilized to program the present-day controllers. Innovativeness can be brought down with the integration of IT technologies. So each and every automation will be unique and customized for the customers. It is more efficient because once it is developed, that can be created as a toolkit. So the another person who wants the similar kind of concept, he don't have to invent the wheel again. So he can take that particular toolkit and utilization. So there are n number of toolkits available for various different concepts now. So finally, it is also future proof. Since it is a software driven technology, so just like we receive firmware upgrades on our smartphone to enhance the functionality and to optimization, so the automation sector or the automation components can also have a firmware upgrade by which we can enhance and optimize the products on a continuous go. So this is very important so that our young engineers will learn, because there is a lot of hints and our government is working towards uh, improvisation in the manufacturing sector. So recently a huge budget was sanctioned for wafer fabrication also. So these are few facts which I had taken. So one of the fact, it was said that by 2021, 6.4 lakh jobs will be lost by IT sector to automation industry. So thanks to COVID, this has been delayed. So it will take some more time for us to gear up, but it doesn't mean that the requirement in IT industry will go down, but the demand will increase in automation industries. Similarly, by implementing Industry 4.0 in the right manufacturing sector can make India a global leader in manufacturing. So this may not happen very soon because our neighboring country has enhanced and they are in a very, very rapid growth level. So in order to gear up, so we have to start implementing this now. So it is not only the core industries, but IT industry also knows the benefit of Industry 4.0, where big IT giants like TCS, Infosys, Tech Mahindra, these guys have started hiring in a very rapid phase. So their IT solution requirement is not increasing, but everybody have understood the potential of Industry 4.0 in the coming days, and those guys are gearing up for the providing services to such kind of industry. So it is very evident that in the coming years, Industry 4.0 is going to play a very, very big role in both in the economical boost also, as well as the industrial growth also. So we have done some work on this. So this is a a recent publication which we have done in collaboration with National Institute of Engineering, Mysore, where they had all conventional lab equipments within their institution. So with some tweaks and modifications, we have developed the indigenous solution in India, and we have deployed that in the institution where engineering students are now working on this particular technologies. So in this regard, recently we have published a journal also. So the link is available. So you can go through it and let us know if you have any doubts on the paper as well as on this particular topic on Industry 4.0. So I guess I'm right on time, and we have some 10 minutes for open discussion. So I'll be happy to answer your questions. Thank you.
Yes, welcome to the floor. If anybody is asking question. It's a wonderful talk, sir. Santhosh sir, very nice.
Thank you, sir.
I think,
sir, good evening, sir. I am Pvt.Ltd.
Yes, sir.
I have a question for you, sir.
Yes, sir.
Sir, it's a very wonderful talk.
Thank you, sir.
Almost we have understood the Industry 4.0. How far it will be useful in the agriculture sector, sir? Can you throw some light on this?
Yes, sir. Sir, agriculture sector also, it is going to change in a rapid phase, sir. Over a period of time, our farmers also slowly, people are moving into the cities, and we have a lot of manpower issues for agriculture. So there we'll be having a lot of sensors which could read the moisture of the soil and everything, and it can be automated, and that is going to take place. So just as a information for you, if you can just Google Tjlc, TULIP. So in this particular concept also, they have done a lot of research for the tulip plants. So that has been in a very high end, where by implementation of sensors and artificial intelligence, machine learning, the plants can talk back to us that I need water, I need sunlight, and these kind of things. And that means it is clearly evident that I can read the quality and health of the plants. So in a smaller scale also, if we can implement this in our agriculture field, so it would be very, very optimal, and there is a huge scope for this.
Thank you, sir. Thank you.
Thank you, sir.
yes, sir. Actually, here in purchase of paddy or grains, actually that customer, that farmer needs some good machines to how is the quality of the paddy, or what is inside in the paddy. These are all actually to be addressed by that 4.0.
Yes, sir.
Because
yes, sir.
In the paddy, so by rough naked eye, we can't see whether in the inside of the rice is whether white or red or
Correct.
immature. Nothing.
Correct, sir. Correct.
Only the technology can give a solution. I think so.
Yes, sir. Now we have the products, we have a lot of concepts. Now we have to bring our young minds into work to develop a lot of innovative things from this.
And nowadays, people are using drones also, drone technology to giving pesticides. And
yes,
then,
sir.
That is also
correct.
Any other, sir? Otherwise, I will invite Dr. Tjlc to give a vote of thanks, sir.
Thank you, sir. Chairperson and their fellow engineers. Today, it was a very wonderful talk given by Santhosh on Industry 4.0. The lecture was very comprehensive, starting from the basics of industry and then history, and then even the components, and then the advantages, as well as the future scope, and also what it can be due to the young engineers and the scope for the India as a country whole. So it was very wonderful talk, and really the fellow engineers might have enjoyed your talk, and I think I felt very useful, and similarly I take it from others also. Maybe they might have enjoyed and useful. And so I thank you, Santhosh sir, for giving a wonderful talk. And I thank all the fellow engineers who have taken some time, their busy schedule, and to attend this webinar to enrich their knowledge in the particular upcoming field for their profession, as well as the day-to-day life activities. And next week, I think we'll have an in-person meeting, as Chairperson mentioned, discussed. There will be energy celebration, energy efficient week, I think.
Okay.
So Engineer Mauliswaran, our senior engineer from the local chapter, he will deliver a lecture on this particular during celebration. So I invite all the members who are present here, and also you can pass on this message to all your friends, so that it will be also given in the WhatsApp group, and the invitation will be sent to everybody. So all are requested to participate in the coming maybe invitation will come next week in person meeting. So with these few words, I thank everyone who participated, and pass on the mic to Chairperson.
Thank you. Thank you.
Thank you. Thank you. Thanks a lot. I personally thank Institution of Engineers, Thanjavur Center, and Department of Aerospace Engineering, Periyar Maniamma University. Thank you, everyone.
Yeah. Thank you. Thank you, sir. And you can end the meeting. Thank you.
Yeah. Thank you, sir.
Thank you, sir. Thank you.
Sir,
Oh.